All right, let's get right into it. We're going to take a look at one of the body's most amazing pieces of biological engineering, a mechanism that works nonstop, behind the scenes, billions of times in our lives. We're talking about the heart's tricuspid valve. Seriously, have you ever really thought about it? That simple, constant love-dub is literally the soundtrack to your life. But what is actually making that noise? It's not what you might think. It's something way more mechanical and way more precise. That's right. That sound is your 4 heart valves snapping shut. And today we're going to zoom in on one of these incredible gates, a key player on the right side of your heart. So let's meet our main character, the tricuspid valve. The simplest way to think about it is as a perfectly designed one-way door. It's all about making sure blood flows in one direction, and only one direction. Okay, so where is this thing? It sits right between the heart's upper right chamber, which is called the right atrium, and the lower right chamber, the right ventricle. Its whole job is to let that deoxygenated blood drop down from the atrium into the ventricle before it gets pumped off to the lungs. Just to give you a sense of scale, the opening it has to manage is pretty big, about 11.4 centimeters in circumference for an adult male. So this is not some tiny little flap, it's a really dynamic structure. And the biggest clue to how it works is right there in the name. Tri, of course, means 3, and cusp is just a word for a flap or leaflet. So it's a 3-flap valve, and that's its secret sauce. Now, to really wrap your head around how these 3 flaps can handle so much pressure without ever failing, I want you to think of a parachute. It's pretty much the perfect analogy, because there are 3 key parts working together in perfect harmony. First up, you've got the main canopy of the parachute. In the heart, these are the cusps we were just talking about. So these cusps are these thin, but incredibly strong and flexible leaflets of tissue. They're basically made from the heart's smooth inner lining, but wrapped around a tough collagen core. This is the part that forms the seal and catches the blood. And don't worry about the fancy names you see here. They just describe where each of the 3 flaps is located inside the heart. The important thing is that together they form a perfect leak-proof seal. Okay, but a parachute canopy isn't much good without its lines, right? Well, in the valve, these lines are called the chordae tendineae. You can think of these as the heart's own heartstrings. They're these super strong fibrous cords that connect to the edges of the cusps, acting just like the lines on our parachute. These cords are packed with collagen, which makes them incredibly tough. They're the reason the canopy, our cusps, doesn't just get blown backwards when the pressure builds. So, we've got our canopy and our lines. What's holding the lines? Well, every parachute needs an anchor. And in the heart, those anchors are the papillary muscles. These are these really cool, specialized muscles that actually stick out from the wall of the ventricle. They act as the anchor point. So when the ventricle squeezes to pump blood, these muscles also tense up, pulling on the cords and keeping the valve leaflets perfectly tight. This is what prevents the valve from flipping inside out, or prolapsing, back into the atrium. You can think of them as the ultimate failsafe that makes the entire system work under pressure. Okay, so we've met all the players. Now let's put it all together and see how this amazing parachute system works, beat by single beat. So first, when the ventricle is relaxed, the pressure in the atrium above it gently pushes those 3 cusps open, kind of like a trapdoor, and the blood just flows passively right on down, filling up the ventricle. And now for the main event. The ventricle contracts with a ton of force to pump blood out to the lungs. This pressure instantly slams the valve shut. The cusps billow out and catch the blood just like a parachute catching wind. The cords pull tight and the papillary muscles anchor everything down. That powerful snap shut, that is the love of your love dub. That's the first heart sound. So you see, when you put it all together, it's so much more than just a simple flap. It's this incredibly sophisticated system, a true unsung hero, quietly working away inside our chests. So let's just recap what this brilliant piece of engineering does for us every single second. It guarantees one-way blood flow, it stops any blood from leaking backwards, and it holds up against huge pressure changes with every single beat. Its closing gives us that classic love sound, all thanks to that perfect harmonious dance between the leaflets, the cords, and the muscles. And I'll leave you with this. This elegant little parachute is designed to open and close perfectly, more than 3 billion times in an average lifetime. It kind of makes you wonder, right? What other absolute marvels of engineering are going on inside of us right now, completely without us even knowing?